Now we have a summary for these two-port parameters. Why we need so many various types of the parameters? There are two reasons. The first is to describe or measure a circuit more conveniently. For transistors, its H parameters can be easy to write out, while solving its G, R, or T parameters is very cumbersome. More importantly, for some circuits, not all parameters exist. We can only use one or two to describe them. For this circuit, we can write out its G parameters equations directly by port voltage current relationship. Now we need to write out its G parameters by using G1 and G2 to describe I1 and I2. The voltage across the 2 ohm resistor is U1 minus U2. I1 equals U1 minus U2 over 2. I2 equals minus I1 equals U2 minus U1 over 2. So its G parameters are 0.5 minus 0.5 minus 0.5 and 0.5. It's a symmetrical two-port. Its matrix G is singular. That is, its determinant is 0. So its R parameters don't exist, and we can't use R parameters to describe this two-port. For this two-port, we can write out its R parameters. The voltage across a 2 ohm resistor equals U1 and equals U2 as well. So U1 equals I1 plus I2 times 2. And U2 also equals I1 plus I2 times 2. These are its R parameters. This is also a symmetrical two-port. Obviously, its G parameters don't exist either. For these two simple examples, you should understand why we need so many various types of parameters to describe the two-port. Secondly, we summarize the methods to find a linear two-port parameters. In the previous lecture, we've introduced two methods. The first one is the experimental method based on the definitions, which means we can get the corresponding parameters by letting two ports be open or short respectively. For some simple two ports, we totally can write out their voltage current relationships of the ports directly by solving these equations and pick up the corresponding coefficients. We can get the two-port parameters. Thirdly, for a linear two-port network without the independent sources, if it's a reciprocal two-port or a symmetrical one, it should satisfy some conditions. Let's summarize them. For a reciprocal two-port, it's G12 equals G21. For the symmetrical two-port, besides G12 equals G21, G11 equals G22. The conditions of the R parameters are similar to those of the G parameters. For the reciprocal two-port, it's R12 equals R21. For the symmetrical two-port, besides R12 equals R21, R11 equals R22. For the reciprocal two-port, the determinant of its matrix T equals 1. For the symmetrical two-port, besides the determinant of the matrix T equals 1, T11 equals T to 2. For the reciprocal two-port, it's H12 equals minus H21. Pay attention to the minus sign. For the symmetrical two-port, besides H12 equals minus H21, the determinant of its matrix, H equals 1. You should remember these conditions that the reciprocal and the symmetrical two-port should satisfy. On one hand, we can get the characteristic of the parameters of a reciprocal or symmetrical two-port. On the other hand, we can determine whether a two-port is a reciprocal or symmetrical two-port by its parameters. Finally, a circuit with dependent sources is usually not a reciprocal two-port. The four elements of its parameters are independent. For the reciprocal two-port, such as a resistive two-port, according to the conditions shown in this line, we can find that it has only 3 independent elements in any kinds of its parameters. Further, if it's a symmetrical two-port, we can find that it only has 2 independent elements. You can simplify the solution by applying these properties.